Well, I'm back. How you doing? So, what we now are going to solve out for is the natural level of output YNT. So, if you see, we've written YNT equals beta plus what the natural level of output was last period, plus that supply shock ST. Okay? So, again, the notion is that the natural level of output is highly influenced by what the natural level of output was last period, plus this growth component beta, plus these productivity shocks ST. Okay, so since this exists in period T, we can also write this as YNT minus 1 equals beta plus YNT minus 2 plus ST minus 1. So what we've done is we've lagged all the time subscripts by 1 period. Because what we're assuming is that the economy is stable, meaning that if this relationship exists in period T, it also exists in period T minus 1. Now what I want to do is substitute 2 into 1. Now this algebra becomes much simpler. So what I'm going to do is I'll say YNT equals beta, then plus YNT minus 1, which is all this stuff on the right hand side. Okay? So, and that's my beta plus YNT minus 1, and then I put ST minus 1 on the outside, and ST's right there. So, this algebra is much simpler than the cyclical component of output, so then I can simplify it and make it 2 times B plus YNT minus 1 plus the 2 supply shocks, ST and ST minus 1. Now what I do is the same substitution. I write down an expression for YNT minus 2, which equals beta, plus YNT minus 3 plus ST minus 2. What I then do is substitute 4 into 3. So what I'm going to do is, I've got the YNT minus 2 equals this. And what I do is I substitute this amount in there for YNT minus 2. And what I do is I get YNT equals 3 betas now. Because here I've got 2 betas and I'm adding a 3rd beta. And then I've got YNT minus 3 plus the 3 shocks. The supply shocks in period T, supply shocks in period T minus 1, and the supply shocks in period T minus 2. Now, if I do this substitution n times, what the expression looks like is this. I've got now n betas plus YNT minus n. That's the natural level of output a long time ago, but here's the important point. Here's the supply shocks, ST plus ST minus 1, 2, and 3 up to ST minus n. The critical thing here is that the supply shocks do not die out over time, they're permanent. And that's really the bottom line of this exercise. Before the ETs died out over time, and we're going to see that when I do the next video. But for now, we see that the natural level of output is a function of all these betas, what YNT minus n was, but then the critical point is it's a function of all the supply shocks, and these supply shocks are permanent. And that's a big deal, and what I will do is emphasize that in the next video. So, again, the substitution's identical. It's just simpler because I don't have a coefficient attached to YNT minus 1. It's 1. And because it's 1, everything solves out much more quickly, but the big difference is these supply shocks are temporary. Are permanent. Getting a little groggy at the end of the day here. Now, what we're going to do in the next slide is I'm going to assume that YNT minus 1 is 0, the beginning period. It's actually not a big deal, but we're going to assume this is 0, and n could be, 1,000 years ago. Okay? So, I'm going to rewrite YNT and YCT on the next lecture. Okay, see you guys in a little bit.